Hi, my name is Sam Cusimano, and welcome to Electricity for Progress. Today, we will be exploring this simple circuit, the DualLEDFlasher. This is the first in a series of CircuitBasics projects that I will be doing. This particular circuit flashes two LEDs using two NPN transistors, two capacitors, and 4 resistors. Here we have two 22K ohm resistors. We have two 470 ohm resistors. These 470s will be used as current limiting resistors on the LEDs. We have two 100 microfarad capacitors. These are polarized capacitors, so you have to make sure that you insert them in the correct direction. We have two 2N2222 NPN transistors, which will be used to flash the LEDs. We have a red LED and an orange LED. Here I have a micro switch, which is horizontal. We have a 2-pin header, male for attaching to the battery box, and a female header for attaching to the circuit board itself. I have my soldering iron at 360 degrees centigrade, and let's start assembling this very simple kit. The effect, hopefully, will be very enjoyable as the LEDs flash and pulse against each other. So let's slide the battery backs out of here and move over our circuit board. The best way to start assembling a circuit is with the components which are closest to the circuit board. In this case, we'll start with the resistors. And you can see that R1 and R4 here, they're marked 220. We're going to use 470 ohm resistors here today. They're quite similar, and really we're using this to limit current going through the LED, so the difference doesn't really matter that much with these two specific resistors. So I'm just going to bend the leads on the resistor, stick them into the through holes on the circuit board, and push it all the way down. There we go. That fits pretty well. On the bottom here, I'll just bend the leads out a little bit, and that'll hold it in place as I put in the other resistors. So let's grab the other 470 resistor, and we'll put it over here in R4. Resistors are not polarized, so it doesn't really matter what direction you have them, but I always like to try and pay attention to the orientation of all my components, so I make sure the stripes face similar ways between each of my resistors. Okay, next we're going to put in the two R2 and R3 resistors, the 22 kilohertz or 22 kilo ohm resistors. These are used to control the timing of the LED flashing along with the two capacitors. So we'll sit that one into the holes, and then again I'm going to bend the leads out to hold it into place. And then we'll take the fourth resistor, this last 22K ohm, and place it in the board. All right. Now at this point, it would be easy enough to place more components into the circuit board and then solder, but I'm an advocate for taking your time, working your way steadily through any circuit board build. And so now that I have these resistors, really the smallest, the lowest sitting components already on the board, now I think I'll pull out my soldering iron, get my solder ready here, and actually attach these resistors to the board. When soldering, you want to apply heat to the component and the board and apply the solder to the component and the board. You don't just want to lay the solder right onto the tip of the soldering iron, but everything's really small here, and it's not too hard to effectively solder these into place. Now I have a fairly high wattage soldering iron here, but this particular kit and the size of these components doesn't really require too many watts for your particular iron. I think any iron should be able to do this. And also be careful when soldering. You don't want to inhale any of the smoke or the fumes that are coming off from the solder. Now that we have all of these solder connections made, let's trim up those leads and move on to some other components. So here I just have some normal wire cutters. Flush cutters work a little bit better than these to get into the board, but you just want to make your cuts right on top of the solder connection without necessarily cutting through the solder itself. Alright, so we'll push all those little cut leads aside, flip our board back over, and it's looking pretty good. So next, let's install our NPN transistors. So these are 2N2222 transistors, and you have to make sure that these transistors are put in the right direction. You can see that there's a flatted side on the face or front of the transistor. And then you can also see on the artwork on the board here, there's a flatted side. Just make sure that you insert each of the pins into the right holes and that your transistor is facing the right direction. If you have it flipped the other way, the circuit will simply just not work. So I'm going to press him in there and then bend the leads out on my other transistor and do the same thing on the other side. And both of these transistors are facing to the right here, I suppose, facing the same direction. I tried to make it consistent. You'll see these LED flasher circuits done in a variety of ways, and you can have NPN transistors facing different directions. You can have PNP transistors above the LEDs. There's many different orientations that you can do for a similar circuit to this. Next, I want to grab the LEDs and put them into place, and the LED also has a slightly flatted side, which allows you to see the direction. Also, there's a longer leg on the LED, and this shows you the positive or the anode. So I'm going to insert the LED into the socket here with the flatted part facing the right direction. And that's my red LED, and then I'm going to do the same thing here with my orange LED. Okay, there we go, and have them just flush against the board. And so now let's flip the board over. Don't let any of your components fall out, and let's solder up these parts. So I'm going to be really careful as I'm trying to solder in my transistor. Solder in the one lead, and then I just usually go to the other side and then do the middle pin. Touch anything up if you're not satisfied with how much solder's gone into it. And again, don't let the solder smoke get you, in the face. Make sure that you keep a distance or have a fan going on. I just don't have my fan running here because it makes a bit too much noise for videotaping. And so now let's also solder on the LEDs. And then once we have all of the components on here, we can once again trim off the excess lead on each of the components. So let's go and trim these off. Also, when you're cutting off the leads of a component, be careful because sometimes they can kind of pop off or fly off if you have a really good set of of sharp cutters. And always wear eye protection, or make sure you're very careful when doing any kind of soldering work or cutting work with these electronic components. Okay. Next, let's put in our capacitors. We have two 100 microfarad capacitors, and these are polarized. You can see there's a big stripe on one side with minus signs as well. One of the leads is longer. Again, the positive lead is the longer lead. And then on the board you can see a circle for each of the capacitors and a little plus sign, so it's easy to make sure that they are in the right orientation. So I will put them both in, and they are in opposite orientations. The C1, the positive lead is on the left, and then C2 here, the positive lead is on the right. So just make sure you put them in the right way. Now we'll flip our board over again and solder in those components. All right, we'll trim off the excess leads. All right, the next components that we're going to need to put on here are the 2-pin header that I have that's going to be used to connect the power, which I'll slide in here in the VCC and ground. And then also I have this little toggle switch that fits in to S1. This is a right angle switch, but there's also some switches that are just facing directly up. With these components in, again, I'll flip it over. Maybe I'll bend the pins a little bit on that power connector just so they're held into place, because now I have some components like the capacitors that are a little bit taller, and it makes it harder to solder everything into place. So just be very careful when you're doing any soldering and make sure that you know the position that your components are in. While you can always desolder something, it's much easier to solder it in the right place the first time. And then I'm just going to press my switch in a little bit more again before I hit it with the solder on these 3 pins. Okay, and we'll trim off the extra leads on the power supply. And now the last thing we're going to do here is grab our battery box, and let's see, we want to have our wires attached to this 2-pin header in order to make it easy to connect that to our circuit board here. And then I see that the leads on my battery box are a bit long, so I'm going to trim them off. And then I'll grab my Paladin wire stripper and strip off a little tiny bit from the tips of the battery box wires. And then we'll tin up the ends of these wires here and then try to solder them onto the 2-pin header to make it easy to connect and disconnect. So let's see, we got those nice and tinned up. I'll now apply some heat to the pin, and there we go. We've got a nice, oh, spoke too soon. It's also sometimes easier to use like a solderless breadboard to hold these 2-pin headers while you're soldering. Just have to be patient to make sure that the solder actually cools off. It's a lot of heat that can go into these little pins, and they hold their heat pretty well too. So now I think we're in good shape. Okay, our last step here is going to be to pop in some batteries. Okay, and plug in our power supply. Now make sure when you plug in the power supply that you have the black wire going to the ground side and the VCC, which is positive power, going to the red wire Very important, there is no reverse protection on this circuit. It shouldn't blow up if you connect it the wrong way, but it's not going to work the way you expect. So we'll plug that in, and there we go. We have a very pleasant dual LED flasher circuit. Now if I hit the switch, the power turns off, and that'll keep the batteries from wearing down. And then if we hit the switch again, of course, boom, our LEDs start to oscillate. The flash rate can be controlled by changing the values of these capacitors and by changing the values of R2 and R3, the 22K resistors that are currently in the circuit. Right now we have about 1 second on each flash, and it's a really pleasant pumming, right, as the lights fade in and out between each other. Thank you very much for watching this CircuitBasics video, our first in a series with this dual LED flasher circuit. Stay tuned for some additional videos on basic circuits like this, other circuit designs in my CircuitBasics series, and explorations of more complex projects. Cheers.